Imagine an object so bright, it makes an entire galaxy look dim. So powerful, it shoots jets of energy thousands of light years into space. So extreme, it can tear apart stars like tissue paper. That's a quasar. And in 2026, we're discovering them in places we never expected, revealing secrets about the universe that are rewriting everything we thought we knew. By the end of this video, you'll understand what quasars really are, why they're so mind-bendingly powerful, and what would happen if one suddenly appeared in our cosmic neighborhood. But here's the kicker. Quasars aren't some separate cosmic phenomenon. They're something you already know about, just cranked up to 11. Let's start with what they actually are. Because when astronomers first discovered quasars in the early 1960s, they had absolutely no idea what they were looking at. They saw these incredibly bright points of light in their telescopes. But here's what freaked them out. These objects were producing radio waves like crazy, and they didn't look like any star anyone had ever seen. The name quasar actually comes from quasi-stellar radio source. Basically, scientists were saying these things look kind of like stars, but they're definitely not stars. Then in 1963, astronomer Martin Schmidt made a discovery that blew everyone's mind. He figured out that quasars weren't nearby objects at all. They were billions of light years away. And if something billions of light years away can still appear that bright in our telescopes, it must be pumping out an absolutely insane amount of energy. We're talking about objects that could be 1,000 times brighter than the entire Milky Way galaxy. Let that sink in for a second. Our galaxy has somewhere between 100 billion and 400 billion stars. A quasar can outshine all of them combined by 1,000 times, from a tiny point at the center of a galaxy. So what could possibly produce that much power? The answer is a supermassive black hole. But not just any black hole, one that's actively feeding. Here's how it works. Almost every large galaxy has a supermassive black hole at its center. The one at the center of the Milky Way is about 4 million times the mass of our sun. Most of the time, these black holes are just sitting there, relatively quiet. They're not actively consuming much material. They're basically sleeping giants. But when gas, dust, and even entire stars start falling toward the black hole, things get wild. Really wild. All that material doesn't fall straight in. It forms what's called an accretion disk. A massive swirling disk of matter spiraling toward the black hole at incredible speeds. And here's where the magic happens. As that material gets compressed and accelerated, friction heats it up to millions of degrees. Hot enough to emit more light than trillions of stars. But wait, there's more. The black hole's magnetic field channels some of this energy into two enormous jets that shoot out from the poles at nearly the speed of light. These jets can extend for hundreds of thousands of light years. That's wider than several galaxies placed side by side, from a black hole that might only be a few light hours across. So a quasar is essentially a supermassive black hole on a feeding frenzy, surrounded by a disk of superheated material, shooting cosmic death rays into space. Metal. Now here's something that'll bake your brain. The energy output of a typical quasar is about 40 trillion times the power output of our sun trillion. With AT, some of the brightest quasars we've discovered are over 600 trillion times brighter than the sun. If you replace the sun with one of these quasars, Earth would be vaporized instantly. But here's what's really cool about quasars. They're not just incredibly bright. They're also time machines. And I mean that literally. Remember, these things are billions of light years away. That means the light we're seeing left those quasars billions of years ago. We're literally looking back in time. The most distant quasar we've found in 2026 is over 13 billion light years away. That means we're seeing it as it was just 700 million years after the Big Bang. The universe itself is only 13.8 billion years old. So we're seeing this quasar when the universe was basically a baby. That's insane. And here's what's blowing scientists' minds right now. These early quasars contain supermassive black holes that are already billions of times the mass of the sun. But how? How did black holes get so massive so quickly after the Big Bang? We're talking about objects with billions of solar masses appearing less than a billion years after the universe began. According to our current models of black hole growth, they shouldn't have had enough time to get that big. But there they are, staring us in the face. This is one of the biggest mysteries in astrophysics right now. quasars are telling us that something fundamental about our understanding of the early universe is incomplete. Now, you might be wondering, if quasars are so common in the distant universe, why don't we see them nearby? Great question. The truth is, quasars were way more common in the early universe. Billions of years ago, galaxies were colliding more frequently, feeding their central black holes with tons of fresh material. Today, the universe is more spread out. Galaxies are more mature and settled. Their supermassive black holes have mostly run out of nearby fuel. The quasar era is basically over. But that doesn't mean they can't turn back on. When galaxies collide, and they do, the supermassive black holes can get a fresh supply of material. The quasar can ignite again. In fact, the Milky Way is on a collision course with the Andromeda Galaxy. In about 4 billion years, they'll merge. And our central black hole might become a quasar. Don't worry though, the sun will have already entered its red giant phase by then. We've got other problems to deal with first. But let's play a fun game. What if a quasar suddenly appeared near Earth? Let's say 1,000 light years away. What would happen? Nothing good. First, the radiation. A quasar 1,000 light years away would bathe Earth in high-energy radiation. X-rays, gamma rays, the works. Our atmosphere would be stripped away. The ozone layer gone. Every living thing on the surface cooked. The oceans would boil. Earth would become a sterilized rock. And if we were unlucky enough to be in the path of one of those jets, we wouldn't just die. We'd be atomized, literally torn apart at the molecular level. Thankfully, the nearest known quasar is about 600 million light years away. We're safe. For now. But it's a good reminder of just how violent the universe can be. So that's what a quasar is. The brightest, most energetic, most extreme objects in the entire universe. Supermassive black holes on cosmic feeding frenzies. They're time machines showing us the early universe. They're challenging everything we know about how black holes grow. And they're proof that the universe is far stranger than we ever imagined. If this video blew your mind, even half as much as quasars blow mine, do me a huge favor. Smash that like button. Subscribe if you want more cosmic mind-bending content. And drop a comment telling me what space topic you want to cover next. Because trust me, the universe has plenty more secrets to reveal. The universe is weird, it's wonderful, and it's waiting for you to explore it. Keep looking up, space wizards. I'll see you in the next one.